Hello and welcome to topic 5. In this topic, we will learn about hashing. Hashing is the process of transforming a sequence of alphanumeric characters to a value. For example, the sequence CAT1 can be hashed into the value 361. The algorithm in charge of carrying out the hashing process is known as the hash function. The hash function receives as an input a sequence of characters and returns a hash value. A hash function can be any function that is able to transform the input sequence into a value. In this particular example, the hash function is the sum of the ASCII values of the characters in the sequence. The ASCII values for the characters C, A, T, and 1 are 99, 97, 116, and 49 respectively. If the hash function simply sums the ASCII values, then the hash value is 361. This simple idea of transforming a sequence of characters into a value has very important applications. I will show you some of them in the areas of security and information searches. Let's begin with its applications in security. The first application is password security. When you log into a server, you do not want your password being read by anyone. You want your password being encrypted and safely transmitted to the server. Well, the simplest way of securing your password is applying a hash function to it. Hash functions are very easy to apply, but very difficult to discover from the hash value. This is why they are also called one-way functions. However, such a simple hash function as the one that sums the ASCII values of the characters making up the sequence is not going to be good for securing your password. First, different passwords with the same characters in just a different order will have the same hash value. We want unique passwords to have unique hash values. Second, it's very easy to guess. Therefore, much more complex hash functions are used for hashing passwords. Hashing as a security tool is out of the scope of this module. However, if you want to find out more, you can search for the keywords secure hash algorithms. A second application of hashing in the area of security is verifying the integrity of content. Imagine you are going to send very sensitive information through the network. How can you make sure that the information you are sending has not been changed along the way? Well, you cannot stop a malicious agent from tampering your file if they have the skills to do so, or avoid errors in the communication channel. But you can alert the receiver if the file has been altered somehow. How? You apply a hash function to your information and send the hash value along with the information. If the file has been tampered along the way, the information received will not match its hash value, and then you know you cannot trust the content of the received file. If you want to find out more about this, you can search for the keywords cryptographic hash functions. Now, let's move on to one of the most used applications of hashing for information searches. This application focuses on making fast searches. Let's understand search with a simple example. You want to know whether a specific number is stored in an array or not. You can do a linear search, visiting each element in the array to check whether the number you are looking for is there. This is the most natural approach, but in the worst case, it might require you to check every single element before finding out that the number you are searching for is not there. Is there a much faster way of knowing if an element is in the array or not? Yes, there is. It consists on hashing the numbers before inserting them in the array. The hash value will tell you where to store the number in the array. In that way, you know exactly where the element should be if it was in the array. So, for example, let's say that the numbers to be stored are 23, 45, 120, and 54, and that you are going to store them in a 4-element array. To determine the positions in which they will be stored in this array, let's decide to use the hash function h of k equals k modulus 4. Thus, number 23 goes to position 3, because 23 modulus 4 is equal to 3. Analogously, number 45 goes to position 1, number 120 goes to position 0, and number 54 goes to position 2. Now that you have preprocessed the numbers by storing them in specific positions in the array given by the hash function, you can start an efficient search process. Let's assume a user wants to know whether number 7 is in the array. In that case, the hash function is applied to number 7. 7 modulus 4 is equal to 3. So, position 3 is checked. Number 7 is not there, so you can quickly state that number 7 is not in the array, having checked just one position and not all positions, as is done in linear search. Now, let's assume a user wants to know whether number 23 is in the array. Again, you apply the hash function to number 23. 23 modulus 4 is equal to 3. So you check position 3 and find number 23 there. So you can state that number 23 is in the array, having checked only one position. When numbers are stored in an array using a hash function to determine their position, that array is called a hash table. Hash tables are used a lot in computer science and will be the focus of our next lectures.